Good morning. Good morning, everyone. I hope you've got coffee, and so because I'm going to be going through this very fast. I have lots to talk about, but it's going to be fun, I think. So, browser testing, browser level testing. I'm sure you're all good people, and you have wonderful aspects, and you have, or you have sugar or test unit or whatever in your backend. What I really want to talk about is taking that further. So, adding to that the kind of things which you don't cover in your unit tests. And in general, if you're doing stuff on the web, that generally means JavaScript in particular, because it's a big and ugly beast, and there are all sorts of things which come in there which can bite you. Now, a lot of you will say probably, well, I have a nice JavaScript framework, and that takes away all the browser-specific differences from me, and it's no problem. And to that, I want to answer a couple of very quick examples of ways how you can still shoot yourself in the foot nevertheless, even with something nice like jQuery. A classic, this is more of an issue for Python developers typically, because they like putting commas at the end of lists. But if you see something like this, you actually get an extra null element at the end in IE, which is just a little example of things which can go wrong quite easily. Another one is if you somewhere have uninitialized variables in your JavaScript and you happen to have some element in your DOM which has an ID of the same name of an uninitialized variable, then IE conveniently defines that variable for you. And if some of your code was accidentally relying on the fact that this uninitialized variable was set to undefined, then you have a problem in IE. So those just as very quick examples. Basically, you can't get around testing stuff on a whole range of different browsers if you're doing stuff on the web and you have more than about 3 lines of JavaScript in there. So I'd like to go through a couple of the ways of how that can be done at the moment, and like contrast them so you get a quick overview of the whole browser level automated testing universe. So we want to test the behavior of your web app through a browser, and there are a bunch of testing frameworks like Selenium is kind of a big one, but Windmill and Sapi are ones which fall into that category as well, which will do that by simulating events in the JavaScript. So it's literally, if you want to click on something, then this click event will be injected into the DOM, and then hopefully will trigger the right behavior, and then that can go back and you can have assertions checking whether the right thing happened. So the typical way how Selenium does this, for example, is you have 2 separate browser windows, or 2 separate browser frames. In one of them you load up Selenium, which is the core JavaScript library, and that receives commands by Ajax saying what it should do, what sort of events it should fire. So for example, it should do a click, and in a separate window you load your example site, say test.example.com, and you say, I want to click on a particular element and check that the right behavior happens. Now, the problem with this is that typically they get loaded from different hosts. So you're loading your Selenium from local hosts, this from another host, and because our browsers are trying to be secure, they say, no, you can't do that because those 2 windows are on different domains. There's a mismatch. Mismatches in port, even that counts as well. So it won't allow that. So the way you get around that is you have those 2 windows and you load your website through a proxy. In this case, say your website is on test.example.com, we'll actually pretend that Selenium is loaded from a path like selenium-server on example.com, and example.com is loaded from that very host, so that's just proxied through. So that way we're injecting ourselves onto the same domain, and that allows the browser to get around this domain restriction. So now creating these click events from one window to another is allowed. Okay, so that's what all of those do, but there are a whole bunch of problems with this way of doing things. One is if you have a website which redirects from one domain to another. So classic would be login via Twitter, where you're going from your site to twitter.com and then back again. Then that will break, because as soon as you leave the domain which is being proxied, suddenly we lose control of that window, and eventually the test just times out. That even happens if you're going between HTTP and HTTPS, although that's often easier to get around. If there's anything you need to interact with outside of the DOM, like any bits of Flash embedded in the page, like pop-up windows, a classic would be like download Windows or file upload stuff. And so generally, you just can't do that because you can't produce the appropriate events within the DOM. You would have to go to the OS level to do that. And it tends to be also really quite slow, particularly in IE. So the second route that people have been taking to address this is the way that Water and more recently WebDriver do it, which is to actually use APIs specific to individual browsers. So this first approach was great because those two browser windows I showed with my IE logo, but could be anything. In principle, it will work with any browser, and the proxy is browser independent. This approach is a whole lot more work, but it actually works a whole lot better as well. So we have a whole bunch of different browsers, and I'll do this with the example of WebDriver first of all. Has anyone heard of WebDriver? Okay, good. Anyone heard of Water? Yeah, expected. So WebDriver is like the more modern, more fashionable Water. I'll come to the distinction later on. It's a project, open source project as well, driven by Google at the moment. And there's some very interesting stuff happening, merging WebDriver and Selenium at the moment. Anyway, what WebDriver does is it has implementations of browser-specific APIs for IE through a common extension, with Firefox through a browser extension. It doesn't have anything for Safari at the moment. It does Chrome via the Chrome extension beta API. Rumors are that there's something exciting happening with Opera that I've not actually seen it myself yet. And it drives HTML unit as well. HTML unit, Celerity, anyone heard of that? Yeah, so basically that's a headless browser. It's implemented in Java, but that's no problem for us. We can still drive it through Ruby, no problem. And the advantage is mainly that it's a bit faster. So because you've not got the overhead of actually firing up a real browser window and actually rendering the stuff. It tends to do things pretty fast. It has the downside that it isn't actually a real browser, and so if you're wanting to really test those fine browser differences, then it won't give you quite the accuracy you want. Water fits very similarly into this kind of thing. It has its own implementation of various drivers. It does Safari, unlike WebDriver at the moment, although quite slowly via AppleScript API, it only works on Mac and not on Windows. It doesn't do Opera at the moment, but it does all the rest. And just for completeness, to see how Selenium fits in there as well, so that has the proxy mode for doing most of these things. Okay, that's getting quite confusing now, so I'll just rearrange that. This is basically the browser-level testing universe at the moment. The various others I mentioned, like Windmill, they fall into broadly the same category as Selenium in here. Interesting is, you can hardly see the difference between the yellow and the green here on this projector, but WebDriver and Water both have quite a lot of green, and they use broadly similar approaches in most of these things. But there's a lot that can be done there by actually merging these efforts, I think. Now, to show you that actually in the fundamental way of thinking, these things are fairly alike. So I've got to actually show you some Ruby code. I haven't shown you yet today. This is a simple RSpec-based example of running a Google search in Water. So anyone who's seen Water will probably be quite familiar with this way of doing things. Basically, before the test, I need to create a new Water browser. After the test, I close the browser, and then within the test, I can go to the specific URL, I can type hello world in the query field, I can click the go button, and then I can check that certain text appears in the page. This is using the Water API. Contrast that with doing exactly the same thing in the WebDriver API. You have a slightly different thing here. It's called quit instead of close the browser. It's called navigate to instead of whatever it was in Water. In principle, the structure of it is very simple. The commands just have different names. Selenium, very similar thing again. You have a bit more boilerplate to get started initially. Slight difference is that you specify the URL hosts up front and then only the path later on. That's so that it can initialize the proxy appropriately. Here it's called browser stop instead of close and quit. It's really important differences. But in principle, you have the same kind of thing. You open, you type, you click, and you check if text present. I didn't mention at the beginning that I started a startup basically doing Selenium in the cloud. And so we've taken Selenium, we put it in a hosted infrastructure, we maintain all various VMs, and we have a nice web front end and a nice test recorder for the whole thing. And just to add to the confusion, we have our own like DSL-like way of doing things as well. This is just built on top of the Selenium API, and does exactly the same as the last example, really only with less text. So that's just a bit of a gratuitous addition. And finally, Cucumber, you can do the whole same thing with Cucumber if you like, and it will look something like this. You have the typical blah blah starting up, and then given that I am on a website, when I enter hello world and I submit the form, I should be shown a list of results and something should appear on the page. This, of course, by itself doesn't actually do it. Under the hood, you would then implement your steps, probably using the Water API or the WebGraph API or whatever. Anyway, so this is the various things we have at the moment. And I think one really interesting thing which is happening at the moment is that Selenium and WebDriver are actually joining forces. And if you look at the repository right now, there's a whole lot of commit activity going on. They've already merged the two repositories together. And the aim is that WebDriver will be used for driving all the browsers, so you get the quality of having individual browser-specific drivers, while keeping the Selenium API, which, although it's a very quirky and strange API, a lot of people are using it and have legacy scripts in that, and certainly won't want to move it to a new API. So, really, in this whole ecosystem, I think the right thing that should be happening is we have one, I'll just say WebDriver for now, and we actually move the Selenium and Water approaches to the back, and actually just make those front ends to WebDriver. Because you saw how similar those tests were. In principle, there's no reason why you can't implement certainly the majority of the Selenium and Water APIs in terms of WebDriver. This Selenium being implemented on the basis of WebDriver is already happening, and they're hoping Selenium 2, which will be based on WebDriver, to be out by the end of next year, and the alpha is already out. It was just released a couple of days ago. This Water on the basis of WebDriver is just a rumor I've heard so far. So it seems that the Water team are interested in doing this and certainly joining forces, taking the best of WebDriver, taking the best of Water. Water is a much older project, of course, and has a lot of experience in it already, so it makes sense to take the best of both worlds there. But then just to get a decent open source browser level testing framework out of this, which then people can use with whatever API they happen to be comfortable with. And I think this is really the best way to go. Okay, pause for breath. This is an overview of what we have so far. What I wanted to give you as well is a quick idea of some of the fundamental, design patterns almost you might get in these sort of tests. And a big criticism which you get a lot with this sort of automated front-end testing is the tests tend to be really brittle, and they tend to break really easily. You just make a tiny UI change and then all the tests break, and then you spend ages fixing the tests. And so there are a few things I'd like to mention in that space, because I think compared to going through that list of 6 or 7 browsers yourself by hand, you certainly won't want to be doing that. So I think automation is still no way around it. One thing which all these browser automation frameworks have in common is this concept of locators. So when you want to say, this is the thing I want to click on, this is the element I want to click on, you have to locate that somehow. And the easiest way of doing that is, I guess, by ID. This is from, I just looked at Wikipedia, and the search box on Wikipedia has various ways of how you could address that. It has an ID, so we could simply use that, which is probably quite a good way of doing it. We could use the name of the form, that's the name of the input element in the form, which might in some circumstances be better if the ID isn't static, for example. Or you could do it by XPath, and you could use CSS selectors. So most of these various frameworks support various different ways of locating elements, and it's worth thinking quite hard about what it is actually. So, for example, I looked at the BBC News website yesterday, and assume we wanted to write a test which clicks on that headline. And kind of the easiest way to do that would be to say, just click on the link with the text, with this text. And that would work fine for about an hour until the BBC updates their website and puts something new in that place, and then the test would break. So really, you probably want something a bit more expressive, saying, by the way, they use tables. Did you see that? So we want to be clicking on the table element, which has this class, and within that, the first div, and within that, the link. And this kind of looks a bit fragile as well, so at least it won't break when they update, when they put a new news story there, but it will break as soon as they redesign their layout a bit and put a div before that. Now, it turns out if you look at CSS selectors, actually there's a really neat way of doing it. They have this CSS class called TSH, which I think in BBC language stands for top story heading or something. And that would probably be quite a good thing. The point I want to make here is that you need to think about these sort of things, and in general, front-end tests are never going to be easy, because people are complicated, and as a result of that, UI is going to be complicated and intricate, and there are going to be lots of little details and niggles. And there are kind of two ways of getting around this. So you could say one, which is the sort of software engineering purist approach, I guess, which is this bottom one. We're going to not work on the level of clicks and typing and locations in the page, because that's party specific. We'll abstract that out, and we'll write to ourselves based on an application, a specific API, which kind of models the concepts and the resources we're dealing with in our application. And then we can write our tests in a nice descriptive fashion, and they'll be a lot easier to maintain because we're not repeating ourselves. There's the other approach, which is kind of completely opposite to this caption, which says, okay, we know that our front-end tests are going to break all the time, so we'll invest really little effort into building them. We'll use a recording tool for writing them, and we'll write as little as possible by hand. And we'll assume that we can only run them 40 or 50 times, and after that we have to throw them away because our UI has changed that much. But that's okay, because 40 or 50 times, that's still giving you a massive increase over testing it manually, and or if the alternative is not testing at all, you've probably caught a couple of bugs in that process already. So I think both approaches are perfectly valid. I think you just need to choose one or the other of them consistently. And so that's kind of something I'd like to discuss with people, with you guys here. How do you feel about this? Do you want tests to be very quickly written and disposable, or very thoroughly thought out and carefully designed? So that's kind of the first level of what I want to say. I guess we could either take questions, or if you want, I've got a couple of more slides on parallelizing tests, running tests in parallel and things to think about in that process. So do you have any questions so far? Please.
You didn't mention WebRat.
I didn't mention WebRat because it doesn't do any JavaScript-based testing, so it only does HTTP level things, which is fine if you have a simple enough application, but it's not actually taking things to the browser level. Anyone?
Do you still think you need to do JavaScript unit testing if you're doing this approach or this?
So yeah, there are some attempts to do JavaScript unit testing. I think if you're doing really complex logic in JavaScript, then yes, of course you've got to unit test it like any sort of logic. If you're just doing bits like manipulating the DOM a bit and turning this into that, those tend to be things which are really hard to unit test. Really, that's something much more fun integration tests, making sure that just the whole thing holds together as a coherent thing. So yes, absolutely. If you're implementing complex data structures in JavaScript, which you might have to do in a bigger application, then by all means write unit tests for those and tie those unit tests up in all browsers to make sure that it works there. What I was focusing on here is more the kind of user story level, stepping through the site, just the very high level, making sure the main functions are there working.
More integration tests.
Exactly, yeah, totally integration tests. Please.
So with Go testing, how does that work? Do we have to run a server that you can see on your service to test that site?
So just for the record, the question was about Go tested our own service. In this one, at the moment, yes, we run the browsers with a partly run Amazon, partly on our own hardware, and we point them at your service from the outside. So if your service is sitting somewhere behind the firewall, at the moment we'd require you to open up one port and forward that through so that we can access it. You can lock it down by source IP, so it's reasonably safe. We are looking at ways of SSH tunneling in, for example, so that way you'd get a more secure way of doing it, or even hardware appliance for larger companies, which you could slot in your own data center and get the same sort of thing, but is still maintained by us. So that, again, is something interesting to talk about later, maybe, if you want. Any more? Or do you want me to go on? Talk?
How long are your exercises?
I can stop short of whatever point, really.
Okay, cool. Let's parallelize.
Okay. One of the real issues with creating tests that are parallel is the database state. So if you're writing unit tests, generally you have a really neat encapsulated world because you've got some sort of fixtures in your database, you set up some preconditions, you do something, you check that the right thing happens, and then you throw away that state again. And that works really nicely because you know exactly what your starting point is. But I don't think we can do that so easily in functional tests because if you're wanting to do front-end tests and you're wanting to run several in parallel, and each of those tests actually spans a whole bunch of different page loads and a whole bunch of different database transactions, you can't isolate them from each other that easily. And so you've got to be a lot more robust in the way you deal with these things. So particularly, tests might be partially run. This is kind of a pattern I see quite a lot. People have an application in which something is created, and they check that it was created correctly, and then they delete it again. And there's an implicit assumption, which is not written at the beginning, which is it assumes that this thing doesn't exist to start with. And of course, this thing fails really easily because you just need to have it bail out some hardware free at one point that's created, and then next time round it explodes when it tries to assume that it doesn't exist. So one thing which I find which works better there is actually change around the order and say first at the beginning of the test, delete it if it doesn't exist. But you definitely have to put that condition into there because sometimes this thing might be there, sometimes it might not. Then you create it, then you check it was created correctly. If you want, you can then delete it, but then since you're doing that the next time around again, you can throw that away. Now, if you've been paying attention, you'll notice that there's also a wonderful potential for race conditions in there. So you're running two of these in parallel, and you do something like delete it over here, and then delete it over here, and that's fine, and then you create it, and then you try to create it again, and then actually you've already got it, and so it blows up again. One thing which works to fix that problem is to actually just run these two things as separate users, and you've got to then have some, in your test running framework, some sort of notion of what users can be logged into the site and make sure that each user is only being used at any one time. But that works quite well as well, assuming your application is such that these things are actually isolated from each other as well. Another thing which happens a lot, it's kind of obvious when you think about it, is you're testing something like a sign-up process, and you run it with a certain username, and this is the GitHub sign-up page, for example. And the second time you run through it, of course, that user has been taken because you've not cleared out the database in the meantime, because there's no convenient point in time at which you can clear out the database, so this corrupt just stays in there. What we've done in Go Test It, and it'd be really easy to do if you want to set up your own environment as well, is to have a kind of special variable name called unique username or unique email address. And every time we run through this, we basically increment a number or increment of this is AAAAAA. Next time we run it will be AAAAB, etc. And that way we ensure that every time it runs through, we get a unique one. And also because it starts with GTI every time. If you want to clear out that sort of nonsense from your database periodically, then you can just filter it quite easily too. And kind of the last thing I wanted to mention, again, kind of obvious, but a lot of people want to test interaction with external services, so like an OAuth authentication with another site. Going back, then again, if you're running several of those in parallel, you're completely out of the space of the universe you control yourself. So you are creating state in somebody else's web application, and you have no way of removing that state once it's been created, for example. So in that case, you just got to be kind of thinking about it and aware of it, that there's this universe outside, and if several tests run in parallel, is that going to blow up on you? So I think that's all I want to say for now. So, any more questions, or we can just move on?
So you said that there are these two approaches for writing the browser-level tests. One of them is doing really quickly and recording it, and the other one is crafting them with an API. What do you prefer?
I personally prefer the quick and dirty approach, actually, to the tests. That's the approach we've been promoting with my startup, I guess. And the reason for that is that the hurdle is just a lot smaller. So you guys, I trust, are probably people who have a very strong sense of the right way of doing software engineering and the right way of writing an application. But with the exception that most of the world is writing horrible PHP sites, and they have no sort of automated tests at all. And so at least if we give them a way to really quickly create something basic, that then takes away that psychological hurdle of creating this first test, and at least there's something there then. And if they have to then throw it all away and restart a couple of times, it's not really going to work because they've only invested 10 minutes in building a test. So I think that's why it works there. I think if you have an application where you know the domain well enough, and you know that it's definitely going to stay within certain bounds, and you can think of a nice abstraction to do it, and it's not too much work, then maybe yes. But I think those will be corner cases where it's worth actually putting all that effort into crafting the tests very nicely. This, by the way, applies very much to the front-end test, not for unit tests. The unit test, I think, is a completely different story.
What are the automated tools for recording these front-end tests?
So for recording these tests, Selenium has Selenium IDE, which is the Firefox extension, which I personally find fairly hard to use. Don't know if anyone here has tried it before. Yeah, it kind of works, but it would need a lot of work, and it's not had very much love from the community recently. Then I think Windmill has its own recording tool, and we could go test it for time. So ours is proprietary, the others are open source. I think ours works best, but then of course I would think that.
Just one thing that we have we tested by stubbing out most of the output services. So you mentioned it works pretty well. So I think we have something I mentioned it's WebRack, but they call Selenium, and then they do most of the output as a little synapse server that works very well. Are there any sort of formalised suites that actually do all this? We've coupled all this together and it's fine. I'm just wondering if there's things that specifically do that. Otherwise, they just test web front end and stub out all the services.
So stub out external services like Twitter in this case, or your internal?
Pretty much any service that goes outside. So we can test we're only interested in the UI, so we can test that from the web, and then anything else goes out to some service which just stubs out and pretends to use information.
Yeah, I've not come across standard ways of doing that. Does anyone else?
I've seen one of the ways you can a lot of them have different backends to the API, so like JKit has different backends. You're right, if you're on kind of fake backend, that's one way to do it.
But in general, I'm not sure with this sort of integration test how much sense it actually makes to stub out things, because really you're wanting to test the integration of everything, and that includes Twitter suddenly changing their API on the whim. And then if your stub version doesn't reflect that change, then you'll just miss things which it uses to test.
I guess we look at it as we want to test our UI from our application, but then whatever Twitter does is separate that from that. So it's not a full integration cycle. It's just saying, well, we want to isolate our bits of the UI, and that I think most effective.
Yeah, it makes a lot of sense. It certainly allows your test to run a lot faster because it's not dependent on external services.
I'm sure you use some kind of fairly big infrastructure in terms of obviously you've got cross-platform. So do you bring it all on virtual machines or?
Yes, sir. Hello, is this off?
Oh, sorry, that's me. Well, this is the last question.
Okay. So the question was about you need lots of infrastructure. Yes, so we have Windows VMs for running the Windows tests. macOS virtualization is still a bit of an issue in licensing terms, so that's actually running on physical Mac hardware. Linux is pretty easy because we can just run several browsers as separate system users. But yes, it does add up to quite a lot of hardware pretty quickly if you want to do things in parallel. But that's kind of unavoidable. Okay, thank you very much.
So